The next question is aniline on heating with concentrated sulfuric acid gives sulfonilic acid. This sulfonic acid now acts as, is it Arrhenius acid? Is it Bronsted base? Is it Lewis base? All the above is the question. So before we answer whether the sulfonilic acid is Arrhenius acid, Bronsted base, Lewis base, we need to know what is the reaction involved between aniline that is reacting with concentrated sulfuric acid. Aniline C6H5NH2. This is allowed to react with concentrated sulfuric acid. Now when you go for heating this mixture, what will be the product form? That is given as sulfonilic acid. So this aniline, benzene amine, aminobenzene C6H5NH2 react with constant sulfuric acid on heating to give what is called para-amino NH2 group here, benzene sulfonic acid. So this is known as para-amino benzene sulfonic acid and is known as sulfonilic acid. Now the question is with respect to this para-amino benzene sulfonic acid. So this para-amino benzene sulfonic acid will act as what? Now in this para-amino benzene sulfonic acid, which when you put it in water, this sulfonic acid group, which is an acidic group, gives the H plus to give hydronium ion as one of the products. So thus H plus is given out by this para-amino benzene sulfonic acid. This has got the tendency to give H plus in water. So any substance which possesses the tendency to give H plus in water is called Arrhenius acid. So therefore it will no doubt act as Arrhenius acid. And it's given Bronsted base, Lewis base, all the above is also there. Therefore we need to check will it act as a Bronsted base. So what is Bronsted base? That substance which will have the tendency to accept the proton. So when we put this para-amino benzene sulfonic acid once again in solvent water, because this nitrogen carries the lone pair of electrons, it will take H plus from water. That is, it is having the tendency to take the H plus and becoming NH3 plus and sulfonic acid. And because of this property, where it is having the tendency to take H plus, it will also act as Bronsted base. So therefore, it is also an example of Bronsted base. Now the third one is Lewis base. And if you can recall, Lewis base is the one which possesses the tendency to donate a pair of electrons. This nitrogen which has got the lone pair of electrons, therefore it will have the tendency to donate this lone pair of electrons to the proton. And thus amino group with the lone pair of electrons is having the tendency to donate the pair of electrons. Hence it acts as Lewis base. And also studied that a Lewis base also can become Bronsted base. So it's already Bronsted base. Now because the nitrogen of amino group of sulfonilic acid has the tendency to donate the pair of electrons, it also acts as Lewis base. So thus it is an Arrhenius acid, Bronsted base, Lewis base. Therefore what is the answer to be selected? All the above. So therefore D is the option.